Okay, let's wait for a few minutes if there's anybody joining. Okay, so let's kick it off. Welcome everyone, and thanks for joining. Today we want to talk about the topic that is becoming increasingly relevant in many organizations. How to get more out of existing SQL environments without adding unnecessary cost or risk. The title of the webinar is More per Core, and that really captures the theme. This is not just about monitoring performance, it's about understanding how SQL environments behave, how capacity should be planned, and how better decisions can be made over time. Our goal today is not to do a deep technical training session. The goal is to show why this matters from both a business and technical perspective, using real customer cases and practical examples. So here is how we will approach the topic today. We will start with why this topic matters now and what we are seeing in SQL environments today. Then we will walk through a few real customer cases and lessons learned. After that, we will show how SQL Governor approaches this problem beyond traditional monitoring, followed by a short demo to make the logic and value more concrete. And finally, we will close with the key takeaways and next steps. I'll briefly introduce the speakers. I'm Joonas Sukanen, Head of Sales at SQL Governor, and my focus today is on broader business context, the customer examples, and the key lessons we have seen across the different environments. And with me here is Jani. Please introduce yourself.
Hello. My name is Jani Savolainen, and I'm founder and CDO of SQL Governor. I have about 26, 27 years background on SQL Server, full stack code optimization from data warehousing to business intelligence and data science. Most of the time I've been involved with the R&D, and I lead our R&D and also I lead our research. So that's in nutshell what I do. So jack of all trades, king of none.
Thanks, Jani. So, this is the core message of today's webinar. Monitoring is useful, visibility matters, but monitoring alone is not enough anymore. A SQL environment needs to be understood, predicted, and optimized as a whole. Why? Because performance, capacity, cost, and operational risks are tightly connected. If you only look at the separate metrics of average utilization numbers, you often miss the broader picture. And that broader picture is exactly where better decisions come from. One pattern we keep seeing is that many SQL environments are functioning, but they are not truly optimized. They may be stable enough, they may look healthy enough, but that doesn't mean the environment is efficient, well-sized, or low risk. Capacity is often allocated conservatively, which is understandable. No one wants slowdowns or outages, but over time, that can lead to oversized environments, uneven resource use, and unnecessary cost. At the same time, structural inefficiencies can remain hidden in the background and weaken the predictability. So the issue is rarely that people are doing something wrong. More often, the environment has simply evolved into something that is no longer easy to understand through traditional monitoring alone. To make this more concrete, let's look at a few examples. The first one is Tampa General Hospital in the US. There, the business driver was re-platforming to Azure. The environment included around 170 SQL servers, and through a continuous optimization approach, significant annual savings were achieved and sustained over multiple years. Jani, you have been involved since beginning, and our software has been used there. So please, could you share some details of this large operation in Tampa?
Yeah, thank you, Jonas. So yeah, this very interesting case, been involved with that many years. Our partner in Florida, Soaring Eagle Data Solutions, was our channel partner in this case. So their skilled DBA experts were there and are there. Our software has been there in this environment and from the very beginning, now seventh year already. So there was a situation because it's a hospital, it's of course hard system. So everything needs to run always 365, 24/7. So it was a great help with our software then to enable the to foresee the capacity needs, the potential bottlenecks in beforehand before they occur, and make as right-sized and consolidated environment as possible without sacrificing performance or availability of the estate. And the kind of environment was mixed. So there was in the beginning it was on premises. There was VMware and Nutanix servers clusters, and then customer wanted to approach to the Azure cloud. And we have actually excellent webinar also from this topic, only Tampa General case. But what is key takeaway from here is that in this case there was a need to lift and shift the workloads first and then to optimize. But I would say I have been involved in like 100 different capacity planning migration cases. So lessons learned from there that always the best option, if possible, would be the first right size and consolidate instead of like afterwards. It's less work in that way. But yeah, that was very interesting case in many ways and still ongoing. So yeah, our software has helped there a lot them approximate from their DBA lead, senior DBA Mike Boschetti was that around 40% savings was actualized there. Yeah.
Thanks, Jani. And that's truly amazing number. 40% savings year after year is something that is quite incredible. And really, as Jani mentioned, there's a webinar just focusing on this Tampa case, and it's still available in our website. So anybody who is interested, you can go and find it there and replay it. Interesting stuff. So, okay. So second example is Visma Solutions, local Finland-based software environment, where the drivers included performance, scalability, and cost efficiency. The key point there is that as the usage grows, the SQL environment needs to remain both efficient and reliable. Jani, again, you have been involved in this Visma case, and our software has been involved there in a significant role. So what were the specific challenges that were drivers in Visma case? If you can elaborate a bit.
Yeah, I think like we have like a collaborative history of 10 years or something like that.
Mm,
So that's very interesting case also. It's a bit different, of course, than Tampa General. It's not hard system, but still very it's a high availability system. So there's
mm,
built a high availability clustering on that. That's more like a bare metal solution from the beginning. And there the clusters are having a lot of SQL Server instances, some instances, and then active workloads. And there is lots of databases. I can tell that nowadays over 50,000 databases, something like that.
mm.
And it drives its own challenges in like a performance optimization, also like a capacity planning. You need to plan and take in count different failover paths. So you know that if something happens and you need to have a failover, is there enough capacity on those situations? You don't want to have too much capacity there and so forth. And there was also cloud transition there ongoing, and we also assisted in performance optimization, so great figures there. And there was several platform renewals over this time of 10 years. So we have also a case reference from this. So there is the case story tells that we achieved quite nice savings also there on a platform and licensing side. Yeah.
Thank you. Yes, that's there's a case reference can be found from our website as well, and we can, upon request, we can open it up much more. Thanks, Jani. And then the third one we want to bring up is a large Nordic SaaS company. There, the cost scrutiny has become more and more important. And the SQL estate itself was a significant cost factor. And as you can see, the numbers, it's not exactly very small environment, it's quite large. And so there, the replatforming and advanced consolidation opened up a very different view of what efficient target capacity could actually look like. So, Jani, can you open up some details behind these quite massive numbers of SQL Server instances and databases itself, and the cost savings that we were able to achieve?
Yeah, this was once again interesting case, very interesting case in different way. Yeah, one of the biggest environments I have worked at, and kind of key challenge in the beginning was that the uh, customer was looking a possibility to drive the workloads from the SQL Server actually to Postgre. But then when we did a profound pre-study on this, because especially of the architecture, how it was planned, it would have been very challenging to move towards the PostgreSQL, and it would have last like many years. And of course, if we think about the costs and TCO and things like that, it wouldn't have been that lucrative case for them. So what made more sense in there was that we enhanced the pre-study, and we actually found out that there is a significant possibility of cost savings from moving from virtualized Hyper-V environment to Nutanix
Hmm.
hyperscale environment, hyperconverged environment, and there we actually made the total topology change. So there are massive servers
Hmm.
and a lot of VMs, hundreds and hundreds of VMs on those physical servers. And we found out that actually, with assistance of SQL Governor software and our IPR, we were able to calculate the optimal redistribution of these workloads, of these VMs and SQL Server instances to a new data platform. And the cost estimate is around 45 to 50% what is possible to achieve there. And yeah, it's still ongoing project, but the migration is there, and yeah, the capacity plan was very interesting to do actually, because when you have a bit higher level of VM condensation, VM cores compared to physical host cores, you need to take in count quite many things. For example, like how many cores you have on each VM, and this affects on OLTP systems. Is it more like when we are talking about chipsets? Is it more a thread rating? Is it more actually overall rating of performance where it hits? And this actually changes based on behavior of the workloads and all the things like CPU contention and different kind of content switching scenarios and things like that. When there is more VMs and more cores, virtual cores against physical cores, more we need to think about these things. And because of our IPR and algorithms, we were able to calculate and see that, hey, actually, when we change the workloads ordering and of course like how they are grouped on the new target servers. Of course, the target servers had also better chipsets, but there is many things where we can make it performing better, and we can make it more consolidated. There is like service breaks, service times, trend extrapolation, benchmark extrapolation, thread rating versus overall rating, and then how we consolidate workloads on different levels of the architecture and topology. So yeah, very good stuff, interesting stuff. And I don't want to go too much to the data science side of this, but I must say that even expert DBA cannot do things what we can do with SQL governance software, because it's quite a lot data science stuff. So we have brought together both DBA and the data science stuff. So that's how it differs from many other tools around.
Thanks, Jani. That's truly an interesting case, and from the business perspective, financial perspective, it's quite easy to see how these savings after these complex operations materialize. When you deploy 50% less cores, you save on the Microsoft server costs, SQL server costs, and virtualization licensing costs. So more per core. That's truly manifesting in this case. So yeah, what we see that different industries, different environments, but very similar pattern underneath. Better understanding leads to better sizing, better planning, and better outcomes. So this is really the key distinction. Traditional monitoring tells you what is happening. It shows utilization, it shows events, alerts, and trends, and that all is valuable, but it is only part of what organizations actually need. If you want to optimize a SQL server environment, you also need to understand why something is happening, what it means in context, and what should be actually changed, as we heard in these previous examples. Pretty complex stuff behind and under the bonnet. So it also means diagnosing structural issues rather than just observing symptoms. It means anticipating future capacity needs instead of reacting late. And it means supporting decisions such as right sizing, consolidation, and platform change on a stronger factual basis. So the issue is not lack of data. In most environments, there is plenty of data. The issue is turning that data into understanding and action, actually. So, and this is where SQL Governor, our software, comes in. And the idea is to bring monitoring, diagnostics, performance optimization, and capacity planning together into one continuous approach. Not as separate, disconnected activities, and not as occasional one-off exercises, but as a more systematic way to understand the environment, improve it, and support better decisions over time. This is an important difference because most organizations do not struggle with lack of tools alone. They struggle with how to connect visibility, diagnosis, planning into something actionable. So at this point, let's make the discussion more concrete. In the demo, we will not to try show every feature or go deep into every technical detail. As you heard, there are plenty. Instead, the aim is to show the logic how SQL Governor helps teams move from simply seeing symptoms and understanding root causes, identifying optimization potential, and supporting practical capacity decisions. That is really the thread running through today's session, moving from visibility to understanding, and from understanding to better outcomes. So with that, let's move into SQL Governor features, and then after that to demo. So Jani, go ahead, please.
Thanks, Jonas. If you can please, yeah, exactly. Thanks. So yeah, so as Jonas said, the philosophy of SQL Governor software is a bit different. It's not a monitoring tool alone. It's not a performance optimization tool alone. It's not a capacity planning tool alone. It's all these three things. Because we often see that our customers struggle with different areas of these, and DBAs need something else than just monitoring. Sysadmin typically works with monitoring, but then on the other hand, everything that is in the monitoring is related to performance optimization, so they are connected. So it needs to be thorough. How would I say, a bird's eye view for both of these areas. So you can drill down, roll up in between the monitoring and performance optimization. So that's justified, of course. And then when you have those baselines and when you have your monitoring data from long term, why don't you use it for capacity planning? It's already there. If you take just a snapshot of your monitoring data and try to guesstimate what is the trend, what is the seasonality, what are the service breaks, the service times, how all these factors affect your environment, it's pretty much guesstimations, and you have to add up at least 50% on top of your estimation to be on a safe side. So yeah, this is one thing. And also on public cloud, if you're going to IaaS, it's not that easy to change everything in there, and on PaaS there are certain limitations as well. So then we are able to forecast our performance, and we are able to alert proactively and to plan the future capacity. So there is lots of patents, both international patent grants and pending patents we have worked with, and we have applied into our software. So we wanted this software to be in the very beginning, like able to forecast things, not only see the current state and the history, because history does not always tell the future. So it helps to predict that, but it doesn't always tell the future. So then our software is scalable from a smaller to from few servers or few 1-2 cluster environments to a great 3-digit numbers of VMs or physical hosts architecture, and it's agentless architecture and actually very simple, scalable, and secure architecture. There is also one picture of it. I will show it in brief. And then, yeah, lots of AI automation there. So that's in a nutshell what the SQL Governor is. Yeah, so here's the architecture. As you can see here, the DB Governor DB is the kind of like a nucleus of this software. So it's running on a separate SQL Server VM, and then there are APIs for user interface, which is React based so application, and then there is an engine, which is actually Windows service that runs different kinds of engines of SQL Governor, which are responsible of different kinds of automations there, like the predictions, the capacity planning, alerting, so forth. And then there is this Spoke API, where the separate Spoke Windows service. It's called agent, but it's not really an agent because it's a separate service, Windows service, and it can be running on a certain AD domain and listening to extended events and DMVs, performance data of different SQL instances, and then relays that data to Spoke API that relays the data into Governor DB. So very simple and straightforward architecture. Yeah. Okay, these are some of the main features. I'm not going to read these as they are here, but you can see that there is quite a lot of different features, but I'm going to pinpoint few of them. So first of all, there is like diagnostics and health checks. So you're able to do the instance configurations, the database options, signal weights versus resource weights ratios on the weight stats. Then you are able to see the missing indexes, unused indexes, fragmented indexes, all these things like the basic diagnostic stuff. Then you're able to see all the time the monitoring status of the servers, instances, databases, volumes, and of course the always on high availability clusters. So if there are availability groups, how they are working, how the data is relayed from AG to second replica and so forth. Then there are different kinds of proactive warnings and alerts, baselining, of course, like what is the normal behavior of each server instance database. And then you can customize your own alerts. Any kinds of alerts you can actually do there. That's also very important to understand that it's not just constrained on the performance counters, but it's also that you are able to do, for example, if you want to see if some SQL Server jobs failed or so forth, you can actually write your own custom alerts there and they just work. Then there are different kinds of prediction functionalities like anomaly detection that tells actually more like what is deviates from the baselines. But then we have anomaly predictions, which is unique. So that is a feature that tells not only like what were the anomalies, but what are going to be the future anomalies, most likely. So it's actually combining the regressions and the anomalies on, how would I say, multi-layer time dimension. It means like, for example, if you have Monday, next Monday, next Monday, and next Monday, so forth. So each Monday. So it brute forces every hour of these Mondays. And see, for example, that if there is a Monday 2 o'clock, next Monday 2 o'clock, next Monday 2 o'clock, and so forth. So if the query plan on inspected database, for example, if the query plan's CPU usage is increasing there, so there's a regression. And you can see that, okay, these data points regression is going to be next Monday on that time too high, for example. So it throws an alert that, hey, this is will be an anomaly over time. And also, it's not only like consecutive days of week, it's also consecutive weekdays. It takes a beginnings of month, ends of month, and so forth. And we have ideas also to applying it in the future to different kind of seasonal breaks and things like that that occur a bit more, not that often, but still they occur. So this is what it can do right now. So and now in addition to that, we have early warnings, which is also a very nice feature. It's quite plain mathematics. I don't tell it in the very detailed, but that I can tell that those anomaly predictions and early warnings are both in patenting in our portfolio. But what I can tell you is that it's very interesting phenomena, because if you imagine CPU usage, so typical CPU usage on server, it lives its own life. It has highs and it has lows, and then it's sometimes very high at long time or very low at long time. Then it can be more volatile or so forth. So it actually inspects different components in statistical matter of each performance counter. So it can understand that, okay, if it's more volatile than it was before, if it's having more regression than it had before, if it has more skewness in the data, so more high values than it had normally. Or if it has kurtosis, so the highest individual distinct values, like long-tailed values on a Gaussian scale, it also understands that, and then it equates all that into one simple traffic light. Is it green? Is it yellow? Is it red? And then it can say, hey, okay, it seems like this and this workload is changing. Like it has like a 3-month baseline, and month after that, if it's changed, it will flag it out before it creates a problem. And then a few words about, which is also a cool thing, we have server and instance uptime and downtime. So every CIO knows that that's the beef, because if you are able to see how much downtime we had per year, per month, per day on certain service or on certain server instance database. So, and we have brought in the service times and service breaks, so you can include or exclude those from these values. So now you're all of a sudden you understand that how many minutes or hours you had downtime, uptime, or which one you are looking at. So on certain period of time. And this makes it for DBA very valuable, of course, because you can say that, hey, okay, it seems like we saved 2 hours and 15 minutes better uptime this year, less downtime, and it means, for example, 500,000 euros or dollars for us per year. That's a good thing. So it also helps DBAs to justify their importance in the businesses as they are. So then, of course, there is different kinds of metadata, as I told, criticality templates for different baselines, like which servers are critical, which are medium criticality, low criticality, like development test servers and things like that. And then we are able to convey the baselines to the capacity planning from different criticality levels. What are the threshold levels for peak CPU, the average CPU? Should there be any time at all CPU contention on the servers and things like that? And then, of course, the continuous capacity management KPIs, different kinds of reports, lots of them, dynamic reports. And then we also have VMware properties API. So from VMware, we can automatically fetch the metadata for the hardware and VM configurations. And then we have also capacity planning templates, not only for typical hardware and typical software and AWS and Azure IaaS and PaaS, but also for the Nutanix, because it has its own CVM reserve. So it has a different kind of calculation logic on the capacity than, for example, VMware or Hyper-V. So yeah, and then we support on-prem to Robo, AWS IaaS, Azure IaaS, and PaaS solutions with our software. Yeah.
Okay, so now it's time for SQL Governor short demo provided by Jani. So Jani, please go ahead.
Yeah, thanks, Jonas. This takes maximum of 20 minutes, and in the QI section you can then bring in the questions, and we leave like a 5 minutes time to answer those questions after this brief demo. If I demonstrated all the features, bells and whistles as written there of SQL Governor, it would take like 2 hours. But now I'm going to show you something, and I hope you enjoy. So just a second, I will share my screen, and I'm going to go through in very brief way, like the main features of SQL Governor software. Then I'm going to show you how I consolidate different VMs to a host pool, derive it there, optimize the workloads against that. So, and of course, same thing would be used against for example, Azure VMs or PaaS managed instances. Okay, So just a second, I'll share my screen. And Jonas, if you can say that you can see then what I see
Sure.
from my perspective. Just a second. All right. Now it should be. Can you see this? Jonas, can you see this? Your voice is muffled.
Yeah, wait a second. I'm not seeing, but
Yeah, now I hear you very well.
yeah,
So you
I'm
can
not.
see this.
I don't see, but
Ah,
yeah, no, okay, yes. It is
you
there.
see.
All good. Yeah,
Okay.
my bad. Yes, go ahead.
Thank you. Thank you. Okay, very good. So yeah, so here's the main view. It's a dashboard, configurable, and what is most important here? I have a ribbon here, bit on my way, so I move it there. Okay, good. So first of all, what you're able to see here is the dashboard, and the navigational elements are here on the left-hand side. I can of course hide them, or then I can uh, add them up here so I see where I am. And then this is the most important part of the navigation. Every view in SQL Governor, and I think this is quite nice, is a tree view. So for example, these are the domains here. And I'm able to navigate in this domain hierarchy. There's like Azure DBs, managed instances, DB Pro is a domain here, SQL Governor is a domain, Workgroup is a domain there. So I'm able to navigate, and when the context is filtered, it means I change the navigational position here in the tree. So it always reacts independent. If I'm going to go diagnostics, monitoring, capacity planning, I always get different view on the metadata if I just click on server, or if I go to instance, database level, well, there's nothing at this instance and so forth. So this is the basic idea. Well, this is not the most interesting part of the software. Let's go to alerts, for example, overview of alerts. And let's take their last 7 days. So now I can see DB Pro domain last 7 days alerts. And I would be able to see from alert to a performance counter, these are the hyperlinks there. So I can see what is happening there on certain, like in database or on server or instance and so forth. I can eliminate database and instance here to see only server, or I take the instance and database, so forth. So this is reactive. I want to see only last hour. Is there alerts? Okay, a couple of alerts is there. 24 hours. Now it's local time. I want it UTC time because I have several geographical domains. So it can be also seen from there. So then what is more interesting maybe is like, okay, we saw that there are lots of alerts and so forth and warnings. So let's go to CPU contention here. So we can see the CPU contention, which is a very critical component. So whenever the CPU exceeds 80% on 5-minute aggregations on any sliding 5-minute window against each given hour, when the CPU is 80% or more and the max CPU queue is 2 times or more the logical core count, or on VM 3 times or more the logical core count, and so forth. So it tells us exactly when the server is going to slow down. And this is something you don't see often. I haven't seen in any other software. It may be in some software, but this is quite unique also, that we actually take all the CPU contentions and see when the servers are slowing down, or they may even halt. So these are critical things always when you see those. Then we have like a weekly statistics on alerts. You can see like a server level, instance level, database level, all level. I want to see only like a CPU specifics or all of them. And then if I want to see some performance counter and so forth, so you can, or only on service time, you can add that tag there. And you can see how it differs from what is the change compared to a previous week. And you can change the weeks from here and so forth. Monthly statistics, pretty much the same thing here. And then alerts per category is like on these categories on instance side or so forth. But what is maybe more interesting is the monitoring. So let's go to analysis monitoring. Let's take last hour, for example. Let's take last 12 hours. We see a bit more data here. So now what we have done a bit differently from maybe like a ordinary monitoring tool is that we actually have combined wait times, as you can see here, to a plan cache. You can see here. So we can see if they correlate for certain servers. For example, if I go to dev here and I see here, okay, this is interesting. Something is happening there on the wait stats. And what kind of weights is weight categories? It's CPU bound and IO bound. And when that is high, also plan cache is high. So this is interesting. I go to a SQL server and DB governor database, and I can see there is that peak. And when I click on that, I can see what is happening. What is the batch total on CPU time, elapsed time, executions, rows, physical reads, logical reads, and logical writes. And here I would see if there was more batch statements in a batch, like which takes how much capacity each of these statements within a batch take, and I would be highlighting the problematical one, so I would see it here. So this is kind of like an easy way to see where the bottlenecks are, and if I navigate back to this top level, I can also do things like, for example, if I go to a different domain here, and let's take this server, for example, and let's see, for example, here. If I want to see some detail, I just click on zoom in and I see much more detailed data then. Now there is not much to show. There is one spike there, but yeah. So I'm able to, oh, it's nicely symmetric. But okay, then I have availability, and this is also a very important thing. So I'm able to see on domain level or on certain server level or instance level, I would see like I take like 24 hours, for example, last 24 hours, I can see if it's uptime, downtime, or let's take 7 days. There is 1 hour when the server has been down, the instance has been down there. It's either down or degraded if it's part of that time slot, not partially, but not fully. And then it's like up or down. So this is how we can see each server instance database, how they are working there in the environment, what's their specific SLA. So, and we can add up there the service times and service breaks as well. Then we have our availability groups. We can go like from domain to see what secondary replica is doing here. For example, this is like a secondary replica to database states, not synchronizing, not ready, reverting, suspended, so on, if there are any problems in those. And I can drill down to a certain instance, and in the instance I can see the AG, what is happening there, not healthy, okay, there is some issue. And then I can see the HC, okay, the estimated data loss quite high, not log send rate or redo rate, anything like that. So I can see immediately what is situation in there. SLAs, so these are basically the KPIs of the baselines. So we can see what are typically how often certain level exceeds on a certain server. So for example, if I go to okay, here's like health score 99.5 means that 99.5% of time the SLA is met. So it's CPU, it's bound to these ones, criticalities. Low, medium, critical, and you can configure your own and adjust these settings. So idea is that, for example, if you have low threshold server, average CPU can be 60%, peak CPU 80%, and then RAM targets 90%, so forth, and what is the SLA for those threshold points, what is minimum cores if you have like a VMs and so forth. So you can configure these and change these, and these are now in our this demonstration environment, so they can look bit funny, some of those numbers, but you can change these as you want to based on your own specifics, like development server, test server, CRMs, ERPs, hard systems, so forth. So they have different baselines, and you often derive them from the actual baselines that you have in the system. If you want to tweak them to more safe side, you can do that, and then it's related to the capacity planning calculations. Then there is diagnostics. So we have different projects here. You can configure them once again wherever you're going. Like you can do one time or weekly or monthly or whatever you want it to be. And then you can see like how they have run those diagnostics on server, instance, database level, results overview, how they have performed and so forth, and all this stuff. Then telemetry data, telemetry management, you can see like, for example, if you want to create a new extended event session that traces all the events on within a certain instance database, so forth, and here is more stuff. So you can select them and you can see then which ones are run and how often. Then there is live workload, when you can see how it's evolving over time. If you have just launched the extended event session, then you have workload history, so you can go to see, for example, this SQL Governor on-prem and SQL Server instance, and this is one of the workload histories. I click on that, so then I can see lots of statistics of that one. And if I go to see certain, let's say I'm interested to see certain batch, what is happening around there, I want to investigate that, I click on it, and then I see how it deviates over time in terms of duration, CPU time, logical reads, writes, how much there is kind of volatility in these uh, individual queries that have run exactly the same batch. So if there is something to tweak, and then like P50, P95, max duration, so forth. So within which range they are at, typically like 50% of the time, 95% of, and so forth of the data. Then there is, of course, sorry.
Jani, one note. Just I forget to mention in the beginning that we have a Q&A active in this session. So I saw Peter, you have hand raised, but please can you type your questions to the Q&A and we can tackle them in the finish after Jani has finished the demo. So sorry for interruption, but and go ahead, Jani.
Yeah, no problem. I promise to leave 4 or 5 minutes to that. So yeah, okay, good. Then there are like fingerprints. You are able to see like which applications take how much of the intensity of the workload in terms of CPU usage. Here you can see, for example, how much it takes, like executions, total CPU percent, and you are able to drill down on a certain application, what happening there, and so forth. So, and also bring in the like server service views and so forth. And then anomalies, basic anomaly detection stuff. So, for example, if we go to let's take last 30 days, so we have some data here. So this shows all the queries on let's say we go to this on-prem instance, and we can see like what kind of regression there is. For example, there is duration regression on this query, and we can see what's the baseline, what's the current, and what is the deviations there, and so forth, and SQL text ID and what the actual SQL text, and all this data is masked. So that is also important to kind of understand that this masked text, even it's telemetry data. Then now let's go to consolidation. So we have like a database, instance, and server consolidation and server right sizing. So I have prepared here, because we have limited time, I have prepared here consolidation project, and I can view this project. And as you can see, there is Dell PowerEdge R960, with 16 cores and 2 terabytes of RAM. I can double click it and I can see what's the CPU model. I can change that if I want to. This is the target planning template. What is the server I want to create this old existing workload to go to? Then like a socket count, what's the OS reserve in terms of cores, how much RAM there is, OS reserve for RAM, CPU growth, RAM IOPS growth. Do I use auto, which means like it's automated, or do I use some annual growth factor there, and so forth. Then like classification, is it critical, medium, or low workload? Now I just have these as they are. And here you can see that, okay, it has 16 physical cores now. And then if I go to certain server that I have actually just like you can drag them from here like this to a new server. But now I have already dragged them here. So you can see this has 16 logical cores estimated, 16, 8, 12, 8, 8, 8, so forth. So it tells that the ratio, core-based overcommit ratio is now like 5.43 to 1, which is relatively high. And I want to optimize because as we can see, these are not optimal ones. Here is quite a lot of space against average and against peak, because average is purple one and peak is blue one. So what I need to do is like 16 cores, 8 cores, 12, so forth. So I just go here and I say optimize. And now 8 cores, 6 cores, 2 cores, 2 cores, 8, 4, 8. And when I look at these, now they don't leave too much space there. So much better situation. And now it just says that, okay, I need actually 24 core and bit more. This is the RAM, actual RAM, what needed. Of course, we want to have a bit more there because we have those RAMs in exponent of 2. So now I just click on process. And now it calculates all the IOPS, the throughput, and all those needs against this host pool, what is needed for those VMs I had just like dragged from the existing topology to this new topology. I can create different brands like Fujitsu, IBM, Dell, HP, whatever. I can put them against Azure or AWS workloads, manage instances, VMs on Azure, so forth. So we support all that stuff. Now it's finished. I can go to view report, and then I click again this view report when I have it. So I can see that, okay, how the cores had changed against this setup, and then what is the benchmark information here. So it uses spec.org benchmarks. So and of course then like IOPS and throughput needs, and then against when they were on Azure but now they are on premises, and then you can see the differences in like logical physical cores, and then the predictive average CPU usage on target server can be seen here, and the peak CPU can be seen from here, RAM usage, and then the IOPS and throughput on each source server, and then all the volumes per server. And you're able to then drill down to instant database level and see all the latencies and so forth. Yeah, and then the last thing I will show is like reporting, of course, the proxies. So those spokes, you can see those health check on those, how they are. So you can configure them and you can see if they're healthy or not. So it's very easy to test connection. So complex thing made simple, just test connection, and you can see everything like how is it working right now there. So you want to need that. So you want to know that everything works on the source servers, everything is fine there, and also on database level, is there every rights granted for the databases and so forth. So yeah, it's all good. So this is super simple to check the status of the surveilled SQL servers, instances, and databases. And then reports, which ends up my demo. So you can, for example, have a heat map here, go to certain, let's say SQL Governor, let's go to DB Pro domain. Here we can see It's very, very busy servers. This is like a CPU usage, and I can also drill down and see the instances. And then I go to a certain month, like December. Okay, there is busy time, 12 to 16, and then here I can see the specific day and the hours, how it uses the workloads. So this was in a nutshell like a very, very fast way. We have lots of features here, just a glimpse of what it can do and all the nuances of the, let's say, more complex features made very simple, like anomaly detections, and early warnings. Sorry, was not time to demonstrate that, but I hope this made you a good understanding what we can do with this software, for example.
Thank you, Jani. That was good. That was interesting. So let's move back to our last slide. And yeah, so I assume this is visible now. So okay, so this this brief demonstration of SQL Governor really ends up our session for today. And yeah, really, we saw, Peter, you had a hand raised over the course. My bad, I noticed it in a bit late stage. I see no open questions in the Q&A. You can still insert them. And really, what we would love to do is afterwards be in touch with you. Any questions, anything you want to learn about SQL Governor, or how it could probably help your environment. Don't hesitate to contact us. You can see our emails. So it's me from sales side and Jani then from the techie side. So please contact us and let's discuss. So now I'm not sure, I don't have the moderation rights. So is there any way that we could grant Peter voice access? If not, then Peter, please contact us or open in the Q&A so we can touch the topic briefly. So yeah, but anyway, so thank you so much for attending. I hope you find this insightful and interesting, and we are really ready now, better positioned in the market than ever before with the up and coming version of the SQL Governor. So let's talk, let's stay in touch, and let's keep those SQL environments safe and healthy and performing.
Yeah, and also thank you from my side. It was very nice to present here. And of course, as said, Peter, if you have any questions, please contact us. We definitely want to help. And sorry if you're not able to now communicate with us through the audio channel, because it seems like there is some moderating problem or something like that. So, but thank you very much.
Yes, thank you.